Hey guys, welcome. This is 5.1 and 5.2 together. So we're going to actually start with 5.1 right now. And here we are. We're at what's called the triangle midsegment theorem. This actually has a vocab word to it. We'll go ahead and talk about that in a moment. But the triangle midsegment theorem essentially is a segment in the middle of the triangle. Okay, and if we're looking at this, I'll read it to you guys out loud. Again, you're going to take note of this, obviously. If a segment joins the midpoints of two sides of a triangle, so here's DE, we know D is in the middle because of these congruent marks and E is in the middle, then the segment is parallel to the third side and is half as long. So we actually know that these are going to be parallel, and it's going to be half the distance. So this right here is very key for us. So we're going to take that information right there, and we're going to go ahead and work it into some problems. And as you guys are going to see, having parallel lines obviously can be very helpful. We had that chapter on parallel lines, and some of those things might pop up again. Okay, so let's move into our first problem together. No, it signed me out. Don't worry, we'll sign right back in. My bad. So, we'll get back to it. 1 second. You can see how I get to this. Isn't this awesome? Okay, there we go, 5.1. And let's get back into it. Okay, so, my bad. Here we go. Let's get started. And boom, we're back. Okay, sorry, where were we? What are three pairs of parallel segments in triangle DEF? Okay, well, according to our rule, we know that if we have mid-segments that we're going to go ahead and get parallel lines. So we can go ahead and mark all of our midpoints. So if you look at it, it says right here DEF, we see that T, R, and S are all midpoints. And because they're midpoints, they're going to make segments that are parallel. So we can go ahead and write those out. So RT right here is going to be parallel. Okay, this segment right here is going to be parallel to the whatever one looks like it's parallel to. Well, it's going to be parallel to EF right here. So EF. And ST is going to be parallel to DE. And this is just applying our theorem. And then the last one, RS, is going to be parallel to DF. Okay, but not only do we create parallel segments with these mid-segments in the triangle, but they also create an opportunity for us to solve. So let's go ahead and take a look at what it would look like to solve in our second problem. So in this problem here, we're trying to find length. So it tells me TUB are midpoints. We want to find the length of TU, UB, and QR. Okay. Well, we got TUB, so I could actually, if I want, I could go ahead and mark in here. I don't have to, but I could. I'm just going to for the sake of it. And I suggest you do as well. Everything I write down, again, you're going to be writing down. So now I know that these are all mid-segments, so we know that segments are parallel like we just looked at, but we're also going to be able to find segments that relate. So I'm going to actually kind of cheat here real quick by using my highlighter to help us find some things. So first thing, let's go ahead, and we know QT. So QT is this segment right here. Which segment is it parallel to? Well, if we were looking back at our other one, it would be UB. Which means, and again, UB was one that we wanted to find, UB is going to be half of the distance or half the amount of QS. So we can go ahead and solve for it. Now this is going to be pretty basic, but we're going to write it out for this first one. QS is equal to 50, right? So if we want to find UB, it's going to be half that amount, so UB has got to be 25, okay? So we just take half the amount, and there we go, we got one piece. All right, so let's go ahead and erase this. I'm going to just erase all of it on here. Let's take a look at the next one, and we'll do a different color here. we want to find TU. TU is this segment here, and it matches with this piece right there. So we know that RS is 40, so TU is going to be half of that. So we get RS is 40. So that means TU will be half of that, so it's going to be 20. Okay, and last but not least, we're going to go ahead and take a look at QR. So I want to find QR. I'm given TB, so those guys can match. So this one's going to work backwards. So if TB is 30, then we're going to double QR. So we have to go back and forth. On this one, we're actually going to make it larger. So QR is going to be equal to 60. And there we go. All set. So that's the triangle midsegment theorem. It makes parallel, and it also is half the distance. So we got to have that in our brains. All right, let's go ahead and switch over. I'm actually going to exit this, and I'm going to switch over to chapter 5.2. I had it queued up, but I'm a little worried that it might have timed out. So let's go ahead over here, and let's jump right in to 5.2. So here we go, looking at 5.2. So this is a start, so if you want to write 5.2 at the top, that's great. We have two essential understandings. Let's go ahead and read those first. There's a special relationship between the points on a perpendicular bisector of a segment and the endpoints of the segment, and a special relationship between the points on the bisector of an angle and the sides of the angle. Okay, so looking at this, we have the perpendicular bisector. I know it's kind of small. Let's see if I can zoom it in real quick to make it easier to see. I don't know if that actually is going to work. I don't think that's going to work. Okay, unfortunately I don't think that's going to work. So we'll just go ahead and use it here from right here. But as you can see, we're talking about the perpendicular bisector theorem. If a point is on the perpendicular bisector, so we got P right here, then it's equidistant from the endpoint. So I can mark from P to A and P to B. Okay, so they're going to be the same distance anywhere if it's on a perpendicular bisector. And then we have what's called the converse. We just are going to take it and flip it. So if a point is equidistant, so if P is equidistant from A to B, then we know that the perpendicular bisector goes through that point. Okay, so two pieces of information right there, and two more pieces of information. So not only do we have the perpendicular bisector, but we also have what's called the angle bisector. And what this basically says, if a point is on the bisector of an angle, then the point is equidistant from the sides. So point S is going to be equidistant, and then we go ahead and take that and we flip it. Okay, so a couple things I want us to write down. I want you to write down those four theorems for me. But here's another thing. We got kind of a cool thing. I can pull up some vocab here, and let's type in equidistant. Okay, hopefully it's reading what I'm typing. So equidistant. There we go. And we want to get this down. Equidistant is a point is equidistant from two objects if it is the same distance from the object. So B is the same distance, so that's how we call it equidistant. So go ahead and you can write that one down. And last one. And the last one is the distance between points on a line. Okay? Nope, that's the wrong one. My bad. 1 second. Let me pause the video, I'll find it. Okay, we're back. I just found it. It took me a while, but here we go. This is our other vocab word. Distance from a point to a line. So basically, this is a great one, by the way. The distance from a point to a line is the length of the perpendicular segment. So if I remember saying, like, what's the closest distance? It's going to be from a point to a line. The fastest way to get from P to line L right here is to take a perpendicular segment. Okay, fastest way. So whenever we're talking about a distance from a point to a line, we're going to be talking about a perpendicular segment. Okay, so both these really help in this situation. Notice S right here is in a perpendicular segment to this line, and that's going to help us find it. So let's go ahead and actually look at a couple problems. I think this might make a little bit more sense once we start doing that. Okay, So first problem, using the perpendicular bisector. So we want to find the length of AB. Okay, so using our theorem, this is a perpendicular bisector right here. So B right here is equidistant to the endpoint. So we know that this segment is congruent to this segment. Okay, so because of that, we can go ahead and just say 4x must be equal to 6x minus 10. And then we're going to go ahead and solve that. Okay, I'm going to actually move the 10 over here and then move the 4x over here. So we're going to subtract the 4x over here. And I'm going to add the 10 to the other side. I just like having positives to deal with. This is going to be 2x, and then over here is going to be the 10, because I added the 10 over. Remember that. Then divide by 2, and we get x equals 5. Now I'm not done yet, because I want to find the length of AB. So AB is equal to 4 times 5, which gives me 20. So there's my final answer there. AB is equal to 20. Okay. So again, that's perpendicular bisector. I know if it's perpendicular bisector, I'm equidistant from it. Let's take a look at another problem. This one would be using the angle bisector. So here's our picture. This is an angle bisector down here. We can see the angle bisector. And notice that this is from the distance from a point to a line, so R has that perpendicular segment. So just like the theorem states, if there's a perpendicular bisector, we know it's equidistant. So these are congruent too. So 7x is going to equal 2x plus 25. Okay, same thing that's going to happen I did on the last one. I'm going to actually subtract the 2x over here in one quick step. And that's really ugly too. Divide by 5, and we're going to get x equals 5. Again, I want to find the length of Rm, so we're going to go ahead and look at Rm as 7x. So Rm is equal to 7 times 5. And when we do 7 times 5, we get 35 as our segment Rm. And we're done. Okay? So guys, just remember those proofs or those theorems are going to be highly important for us to get down and know: the perpendicular bisector, angle bisector theorem, and the triangle midsegment. So we got 3 things that I want you to be focused on over this weekend. So good luck. See ya.